Hello, we'll be looking at header files in this lecture. And what I'm going to do is the following. We had this program image.cc which was used to read a BMP bitmap image file and display uh, the same image as a text art. So we had this file, we wrote this program which could do this. Now I want to provide this program as a package to others. Let's say someone else wants to use this package. Someone else also wants to read a bitmap file and wishes to do something with it. Or he or she would want to use our write BMP function and write a picture, right? Or create a new bitmap image. People might have multiple uses of the package which we provide. To create a package first, I will have to. So here is the idea. I will provide a header file in which all the functions, the types of functions, not the function body, but the type of function. What is its what are the input parameters of the function and what is the return type of a function, etc. That is the type of a function. So the type of the function and the definitions of the structures, like this, what you right now see on screen, these are definitions of structures. These are combined and encapsulated, collected into one header file. Okay, now along with it, I will also create a library for this in our program. So basically a library for reading and writing of bitmap images along with the capability to even display text art. So that's the plan. And what is the use of this library? Now a separate main, someone who is going to write another C program can now write a program which can access this library. That's the thing. Just like as you right now see on screen, there is a std, standard input output library, standard stdlib, standard library, etc., string library. These are libraries provided by some others. Okay, and they provide the header file for us to see the definitions and the types of each functions, and we use that to understand what is the type of different functions, etc., and we call those functions. When I use a printf or a scanf, I am actually calling the library function provided by the stdio library. Okay, similarly I would like to make an image library, and this is the aim of this lecture. Okay, now to do that, first thing is I'll have to create. So this is image.cc. This is my this is one huge file in which we did everything. And before I make this into this header file and cc and create a library, I'll first have to make some corrections in this program. Okay, I didn't corrections, not as in there is an error here, but the program is not written well in some sense. For example, I said open BMP file. What does open BMP file means? What we would we think is that it opens a BMP file, right? And but that's not the only thing it does. It also creates a new BMP image. So it creates a black and white image, for example. It it writes into this text. It converts into the text and displays in the text. These are not part of a read BMP file function, right? So what should the read? So let me just call it read and just read. What is a read function here in this? So maybe the best thing is read BMP, right? Because I'm going to read BMP. So what should the read BMP file do? It has to read a BMP file which is given as input. The file name is given as input. It has to read that BMP and return the BMP structure. That's what I would like to do. So where do we have a BMP structure? No, we don't have a BMP structure. So let me just create a BMP structure. What should the BMP structure consist of? So it should have construct, so struct BMP, and it should have a few things. It should have, first of all, it should have the bitmap header file. Okay, and then it should have the DIB header. Then it should have the image. This is my struct BMP, and this is the structure. It's going to return a pointer to such a structure. Okay. Now, so it's going to return a pointer to such a structure. So struct BMP star. Clear? Clear. Now, and so once I do this, I need to do the following. I have to create a new BMP file, and I have to call right, and I'm going to call struct and malloc size of right, and then I don't want these two things. Right? I'm going to remove this. Next, there's no header now. It's BMP header, right? So I'm going to make it into BMP header now. So this BMP header dot name, and this is, I have to pass the address of BMP header dot size, right? And here it is. Let me just copy. I'm just going. Since I have this structure, I am giving, and the structure has the header inside it. So I'm giving the. I'm just making this header. I'm just taking the header information into the structure, right? Okay. This is DAB header. That's also part of our BMP structure. Right. I hope I got everything correctly. And here there is. This image is also, this is also part of my BMP structure. This much is good. Now I don't want to convert the image to text or to create BW image, the black and white image, right? Neither do I want to free the image right now. That's not part of this function. This function's aim is to create a BMP image and return it. So I'm going, let's just copy this down here, and we will use it. Right. And now what am I supposed to return? I'm supposed to return this BMP because that's what I said. We said that we will return this pointer. Now, few things. So this has to be null pointer because the file open did not succeed, so we have to return a null pointer. And same here also, we have to return null pointer. But there's one more thing you need to do. What is it? You have to, what is it? Try to recall. You missed doing something else. You didn't free this malloc, right? Because if you are returning null, that pointer is lost. The pointer BMP, the structure which was allocated, that's lost now. And you should free all your memory allocations. So that's what we did, and we have to do this here also. We did this here also, and there's so now fine, right? So this is the read BMP. And what about write BMP? Again, the write BMP should take, what should it take? It should take a BMP structure, say pointer, and that's it, and maybe a file, right? That's all it should take. And I'm going to do that. I'm going to make those changes here, and the file name is going to be the file name which is passed. That's the name of the file to be written into. Return int is fine. Okay. Now this, rather than pick, it has to be BMP image. Sorry, let me copy BMP, and I'm going to copy that, paste it here. Do you know why I'm using, why I used the bracket there? I use the bracket here because I don't know what is the ordering here. So there is a particular, so if I have written address of BMP arrow header, is it going to be the address of BMP header? But right now what I want is address of BMP header dot size, right? So I just want to bracket it. If you know the correct ordering, and you can use it without, if it works without bracketing, please go ahead. But bracketing makes sense because you can understand things better. Okay, so now this is something which you can write, and there is image to text. Good. Did I miss anything? No, this looks good. Right now we have the file. We have the image.cc, and so let's do one more thing. I'm going to have, if I'm going to say that you want us to pass two parameters. If the first parameter is pass, it's going to just print and display it on the screen using text art. If two parameters are passed, then it's going to write that. Okay, right. It's going to write it into that file name. So pmp comma. So that's not create black and white image. What is create black and white image? Right. So this is not. I didn't want create black and white image. I wanted a write function, because there's a read BMP function. There should be a write BMP function. I just remove the create BMP function. That we can use it outside. If you want, we can use it. Right. And now I have. Let's say struct BMP star BMP is equal to, you know that this open BMP is going to, so this is open read BMP, then this has to be write BMP, right? So this is read BMP, and what is image to text? It's going to convert the image into text, right? Right. Now that's fine. Now the second function is called only if, okay, so only if this arg2 is less than 1, I'm going to write this. Sorry, less than 2, we'll have this command. So if it's just a dot out, then we are not going to, we are going to return, right? Because it means that there is no input file to this function. Imagine, I mean, what did this program do? This program is going to take a file name in the terminal, and it's going to read, so a file name which is a BMP image in its terminal, and the program was supposed to read that BMP and display it as an ASCII text on screen. So that was what this program did. And right now what I did now is that I just said that, okay, if the number of arguments is one, that is, if it is only dot slash a dot out, you're going to say, okay, that's not the way to use. You have to say, uh, let's say input, you have to say something like dot slash a dot out input BMP and then output BMP. Okay, so it comes here if it only if it's greater than one, and if it's greater than one, it's going to read the BMP and it's going to print show the image on screen. Okay, and if it's greater than, let's say, 2, which means there is a second parameter also, right? So it's a dot out input and there is an output also. So if there is an output, then I'm going to write a black and white image into the file, a black and white image into file, and this file name is output.py. Uh, uh, that's the sorry, its file name is given as a second argument. That's what we wanted to do now. Okay, but this is not part of the package, right? This is not part of the package. The package is supposed to be only the read and write of BMP. Now, so this has to be separated and separated out into a new file. What is a new file I'm going to call? Let me create a new file and call it, just call it bmp.cc. Just call it bmp.cc, and I'm going to include, okay, wait, before that, I need to have, I'm going to create a header. The aim is to create a library for this, right? So I'm going to create a header file now, and the header file is going to contain all this. What is it going to contain? It's going to contain all the structure definitions and the input type. So let me just create a new file, and the new file is going to, I'm going to copy all the structure definitions from here. Copy that. The body of all the functions will remain in CC. I'm going to paste it here. I'm going to save it as image.h. And this function, I'm going to, and in this header file, I'm going to have all the function types also. So what is a one function? This is the read images one function type, which I'm going to copy here. Okay, so this is a function read images one. So you can see read images one function type, which has which takes a file pointer and etc. Now, free image is next. Okay, I'm going to copy it one here and then copy it together. Okay. And I'm going to copy all of them here. Yeah, so this structure is, let me just copy this image.h here. So I have to include this image.h because all the structure definitions are there, right? And the bmp.cc, we can now, our aim is to use now, so hash include, our first aim is to compile, let's say I'm going to compile image.cc. Okay, I'm going to compile image.cc. Let me see what happens if I just compile it like this. So it's saying there is no image.h file. Where is the image? But I just created an image.h file. No, the thing is, if I write image.h between this the greater than and less than, the less than and greater than symbol, it's going to check in the directory where all the other header files are there. With this path is set somewhere. It's set in your computer. And so, for example, your string.h, std, io.h, they are all in that particular library, and that path is there, is part of your terminal path. So I have now I want to force it to read the see the image.h in the current directory, and therefore I can put it in double quotes, and that should work. So I put image.h in double quotes, and this should work. And now let me just compile, and it compiled. It says that it compiled well, but there's no main. So without main, what is it supposed to do? Right? So suddenly the compiler it has compiled well, but it's not able to form the a.out out because there is no main to start running the program. That's basically what this is saying. So I want to tell the compiler that no, don't worry about me. Just give me the output file as a library. So for that, I'm just going to say only compile. That's minus c, it's compile. It's like compile only. And then I do, okay, it's compiled properly. So it has compiled, and you can now see this. If you type, you can see an image.pop. You see an image.off file, and that's the compiled output file. Now next thing I want to do is I want to run this pmp.c file, right? And again, you would have noticed that, okay, so there is an stdio. Oh no, I wanted not the stdio here, I wanted the image.txt, right? That's what I wanted to do. And anything else I want to do? No, that's fine. Right. So I have to include that. So let me now compile this and see. So now when I have to compile, so let's first compile, and it's saying undeclared use of image. There is what is image? There is no image, so it has to be bmp. Right? It has to be bmp.image, and that's what I did. And here, I also didn't free this bmp. Good, we noticed that I have to free bmp because this bmp was created allocated memory in the read bmp function. So I need to free that. I just did that now. And it's saying it does not know what is free. Where is free? It does not know. So let's include that. Hash include std.h, and it does not know printf. Where is printf? Okay. So let me include that. Hash include std.io.h. It's saying again. It's saying it's all compiled. It all looks good because all the types, everything is correct. Because I looked at the header files and I saw that, okay, the read bmp and the image to text, they are all following the type, the correct types. So all those things are correct, but I don't know where is the code for read bmp and where is the code for image to text, etc. Can you give that link to that? I searched in the library folder and I couldn't find. So let me just I have to give that now, and I'm going to give that by just typing like this: it's gcc bmp.cc and image.o, as you could see, and I compile. It's compiled. Now you have a /a.out which should work, and I'm going to do that. I'm going to type sachin.bmp here, but I'm going to make it into very small. And now let me enter. Can you see that? Or Sachin has come. It's good. So now this is a package. That's the main thing. I have now an image.c, an image package which anyone can use now. Just put the header file and use it. So If you want to use it just like you use an stdio dot head stdio file, the standard input output file, etc., all you have to do is copy this .o image.o file and put it in your library folder, and put your header .h image.h file also in the header file folder where the stdio.h file is located. Copy your image.h file into where the stdio.h file is located. Copy into that folder, and similarly copy the image.o file into the folder where stdio.o file is located. You do that, and then you can do it just like you you can use this package just like you use the stdio package. You have successfully converted this into a package. That's it. Now, the main reason for doing so, why did we do this? That's the main question, right? Anyway, the earlier thing worked, so why was there a requirement to do this? The reason is that I do this. First of all, I can get a package. This is good. Now others can use it. And second thing is that now, so okay, but why did I make it into this header file and etc., right? And the reason is that now tomorrow I come and I change it, I come up with a different way to solve this. To maybe I have a better way to write a read bmp file, or maybe there was a mistake in my write bmp and I had to change it. So if I later, sometime later, I have to change it, all I have to do is that I have to change, I have to release a version 2.0 of this image cc, that is version 2 of image.o file, and I have to just ask the person to copy it in that folder for the library. Just copy it there, and then it will start working. You don't have to. This multiple people can use my package, and I using these functions, and similarly, I from my perspective, I am free to modify all these things to release version 2, 3, etc. I have all those flexibility, and that's one good thing about all this packaging. And this is a better way to write code. And since till now I never told you about these things, I never asked in your assignments to write like this, but henceforth I will expect that all your assignments you are going to write, you are going to create header files, you are going to create cc files, and separately you will have a main file which contains the main program. Main program means where the main function is there, and you're going to use this package model is what we will be working with. Okay, now header files henceforth are compulsory, and I didn't do some things like you should have your name and details in this header file. It's not because I'm going to correct your assignment. That's the best practice for writing program. You should have your name here as a comment, and along with what this file does, what is the objective of this file, and the author names of this file, and better to have when was this file created. This kind of information is important in all header file, all files, like all header file, all cc files, etc. You also should give comments about this is something which I have told, comments about the structures and functions, etc. Right, that's it. Thank you.